Hey guys, and welcome back for another lesson on factorizing quadratics. My name is Miss Danielson, and today we're looking at factorizing two-term quadratics. I hope you joined us for our previous lesson on factorizing three-term quadratics, as well as our introduction to quadratics. If not, I'm linking them down in the description box below. Otherwise, let's get started. Well, the general format of a quadratic is still ax squared plus bx plus c. A two-term quadratic might be where one of those terms is missing, so either a, b, or c is equal to 0. A must never be 0 because if a were 0, the first term disappears, and that's the x squared term. Without that x squared term, we're just left with bx plus c, which is a linear equation. So let's start with where c is equal to 0 then. This is the easiest quadratic to factorize because when the last term is equal to 0, we're just left with the x squared term and the x term. So here's an example. I've let c be equal to 0, and I've even written that for you. So you can see it started with 3 terms. I've still got the x squared term, minus 12x plus 0 can simplify to just x squared minus 12x. That is not a linear equation because it's still got an x squared term in it. That's the most important term to define a quadratic. And it's got an x term, and these two remaining terms have a common factor. They've got a common factor of x. So when I want to factorize this kind of quadratic, it's the easiest kind. I'll just factor the x out. I don't need to set up two brackets this time. I just put x outside of one set of brackets. And inside the bracket, I say, if I divide x squared by x, what would be left? Just the x. If I divided minus 12x by x, what would be left? Just the minus 12. Or maybe an easier way for you to think about that, when I factor out the x, what does that x need to be multiplied by to make x squared? X times x makes x squared. And now what does that x outside need to be multiplied by to make minus 12x? X times minus 12 would make minus 12x. So this is now my factorized quadratic, and it was a nice, easy one-step factorization. Let's see another example. So again, I've got a quadratic here because it's got an x squared term, but it's only got two terms. I'm missing the last term. There is no number term on its own. I just have an x squared term and an x term. And as always, when the last term is missing, the remaining two terms do have a common factor, but be careful because this time they have more than just x as a common factor. A factor could be a number, a letter, or both. And in this case, I definitely see they've got a common letter, but they also have a common number. Both of these terms could be divided by 3, and both of these terms could be divided by x, so we could factor out 3x. Again, to figure out what goes inside those brackets, once I factored out 3x, you think, what do I have to multiply 3x by to make 3x squared? I've already got the 3. I've got an x. I need to multiply x by x to make it x squared. And then what do we have to multiply 3x by to make 15x? Well, I've already got the x out front. I just need to multiply the 3 by something to make it 15. 3x times 5 makes 15x. And that's how we factorize those ones. So those ones should be simple. As long as you recognize that there's a common factor, you don't need to set up two sets of brackets. It's simple. Now, what about a two-term quadratic where the b is 0? So if there's a 0 here, we just have an x squared term and a number term, like I've got down here. Right? This can simplify to be x squared minus 9 instead. If the middle term is missing, this is something that we refer to as dots. Difference of two squares. We'll get into that a little bit more just a little bit later. But all of these are considered dots. Where the middle term is missing, I've got x squared minus some number. X squared minus some number. They're all the x squared term and some number, right? Except for this one and this one. There's a little bit more than just x squared there. We'll get into that too. But these are all dots and they need to be factorized a different way. So remember our old method. We are going to use this old method, but you're going to see it's actually easier when it comes to dots. Our old method is we look at a quadratic and we think, I need to find two numbers which multiply to make c and add to make b. I know that to get the x squared, I've got x times x, that'll make x squared, but multiply to make c and add to make b, when c, the number term, is negative 9, but b, there is no b. b is gone, which means b is 0. In a quadratic where b is equal to 0, we have to keep in mind the kinds of numbers that add to make 0. What kinds of numbers add to make 0? 2 positive numbers, a positive and a negative, 2 negatives. They must be the same number, but one positive and one negative. That's the only way they're going to add to make 0. So, explaining a little bit more about what dots are. Dots stands for difference of two squares, and I'm using the colors here to explain this. The pink here, the difference, a difference is a subtraction. So to find the difference between these two terms, x squared minus 9, I subtract. So a dots will always have a minus there. 2 squares is because the two remaining terms, the x squared and the 9, they're squared terms. X squared is obviously squared, and 9 is a square number. It's a value that could be square rooted. So that makes things a little bit easier for me when I'm trying to figure out what numbers do I need to put in here. I know they need to be the same number, but they have to have a different sign. So what same number multiplies by itself to make 9? 3 times 3, right? But I don't want to make positive 9, I want to make negative 9. And to make a negative number by multiplication, they've got to be opposite signs. So I've got positive 3 and negative 3. Or negative 3 and positive 3. Either way is fine, right? I can do my little check to make sure that that's right. And you should do this check to make sure you got the right signs. So multiplying that through then, x times x would make x squared. X times minus 3 makes minus 3x. 3 times x makes 3x. And positive 3 times negative 3 makes negative 9. Remember those middle two terms, they do group together, they're like terms, and negative 3x plus 3x makes 0. So that leaves me just with my x squared and my minus 9, nothing in between. Try another one. This one was a bit more challenging, and I know that you're going to see this one and think it's completely different, but it's not. It's a difference of two squares. I've only got two terms here. It's definitely a difference. I've got a minus in between them, and the first term may take a little bit of thinking, but it is a perfectly squared term. Something multiplies by itself to make 4x squared. And the last term is also a squared term. Something multiplies by itself to make exactly 1. Right? It's a difference of two squares. The thing that multiplies by itself to make 4x squared, 2x times 2x makes 4x squared, right? 2 times 2 makes the 4, x times x makes the x squared. Now to get the last number in this bracket, number that multiplies by itself to make 1, and the signs are opposite, positive 1 and negative 1, or negative 1 and positive 1. Order doesn't matter. One of these answers, either one would be fine. Quick check. If I were to multiply that out, 2x times 2x would make 4x squared. 2x times negative 1 would be minus 2x. And 1 times 2x is 2x. 1 times minus 1 is minus 1. Those two middle terms, they group together, they cancel themselves out, which leaves us with just a difference of two squares. It leaves me with the 4x squared minus the 1, just as it should be. Right, time to get some practice in then. Notice that I've organized this for you again. The first row here is all the same kind of two-term quadratic. Are they where the C term is missing or where the B term is missing? If the C term is missing, the two remaining terms have got a common factor, so you only need to set up one bracket and the common factor goes out front. If it's a difference of two squares, then you need to set up two sets of brackets, but it should be easy to figure out what the number is because a square number could be square rooted, and we use that square root plus or minus. Okay, so the first row here, those are where C is missing. The second row here as well, C is missing. All of these questions here have both the x squared term and the x term. The next row here, oh, I don't have an x term. I've got an x squared term and I've got minus a number. X squared term minus a number. X squared term minus a number. Those are all difference of two squares. Now we're getting on to some ones that have got stars next to them. Maybe they're difference of two squares. Maybe it's where C is missing and they've got a common factor. You're going to need to figure that out for yourself. And this one down here with the double star, you need to think carefully about that one before you do that one. The answers are going to come up in a minute, so you're going to want to pause this and work your way through this. Don't peek at the answers until you have to try on your own first. Okay, so hit pause and the answers are coming up just now. I wasn't going to give them all to you all at once. Here comes the next one. Okay? And that O had a common factor, but there's more to it than that. Look at what's left in the brackets. Difference of two squares. Did you notice that? Let me know down in the comment section how you did, and feel free to ask for any help on any doubts you might be having. Otherwise, just keep practicing, and I'll see you soon.